Okay, so we're going to talk about algebraic expressions and solving some two-step and maybe it may take a couple more steps for some of these problems, equations. So, and there's a couple ways you can work this. I'm going to try to show you guys the quickest and easiest ways. So for this number 1, remember that we always want to isolate the variable. We want to get the variable x in this case all by itself. So in order to get this whole expression, this x plus 5 by itself, I noticed that it's kind of attached to this 17 that's being multiplied by the entire chunk. So if I want to get this 17 out of the way, what I would like to do to make it simpler is to go ahead and divide both sides of my equation by 17. So I'm going to go ahead and do that. Now, there are some people who want to distribute this 17 through. That's fine. I don't care if you do that. But this is going to be a little bit easier in the long run, okay? So I'm going to go ahead and divide both sides by 17. When I do this, remember that when you do the inverse operation like that, this 17 and this 17 cancel off. They're gone. They're no longer existing on that left side of the equation. And if I want to rewrite what I have, now on my left side, like I said, the 17s are gone, and we only have x plus 5 left. On my right side, I have 0 divided by 17. Well, anything divided by 0, or 0 divided by anything, sorry, excuse my language, will just be 0. So we'll be left with 0 on the right-hand side. From here, it's just a simple, nice little quick problem. You're going to, if I can get my red back, we are going to subtract 5, because we notice that we have plus 5 right here. We're going to subtract 5 on this side to get rid of it. As I said, we want to isolate the variable. We want to get x all by itself. And we will be left with just an x on the left side. 0 minus 5 gives me a negative 5 on the right side. And that's your answer. Okay. The next problem I have here is 7 equals 10 minus g over negative 2. As always, I want to isolate my variable. In this case, my variable is g. So I want to get all this other mess away from it. The easiest thing to start off with is to go ahead and just multiply both sides by negative 2. So that's what I'm going to do so that I can get this negative 2 out of the bottom. I don't like having that fraction there if I can keep from it. If I multiply that side by negative 2, I have to multiply this side by a negative 2. So now I have on my left side of the equation, if I say negative 2 times 7, I will get a negative 14. Here, my negative 2's will cancel out. They're no longer there. Okay? And so I will just be left with 10 minus g. From here, I still am wanting to get g by itself, okay? So my problem is that I've got this 10 here. I know that this is a positive 10. I can write that in there if that helps me. In order to get rid of a positive 10, I need to take 10 away. So I'll subtract 10 on both sides to get it away from that g. If I have a negative 14 minus 10, that's going to give me a negative 24. I no longer have these 10s here, but notice right here we have minus g. We've talked about this before as being the same thing as plus a negative. What we have on the right-hand side of the equation is a negative g left. Okay, so we still have not solved the equation for g. We've solved it for negative g. But if negative g is negative 24, we know that a positive g should just be a positive 24. Okay, and that would be my answer. Go to the next page. I've got this problem here, negative 7 equals negative 11 plus v over 5. As always, I want to isolate my variable. In this case, my variable is v. It is stuck inside of this little quotient here, this fraction. So I'm going to work to get this guy by itself first, that whole chunk where the v is stuck in there. So I'm going to go ahead and move my negative 11, and if I have negative 11, then I need to add 11 to get rid of that. Do the inverse operations. If I add 11 on the right side, I have to add 11 on the left side. So on the left side of the equation, I have a negative 7 plus 11. So that will give me a positive 4 on the left-hand side of the equation. My 11s are now gone, and I have v over 5 left. To solve this part, I need to do the inverse operation. Notice that v is being divided by 5, so I'm going to have to multiply by 5. And if I multiply by the 5 on the right-hand side, I have to multiply by 5 on the left. So on the left, I have 5 times 4, which gives me 20. On the right-hand side, I have these 5s that cancel off, and I will be left with just v. So I get 20 equals v. One last problem. This one's a little bit messier. So I see that I've got 2 x's in here. Okay, so this is going to be a little bit more of a mess to untangle, but I really want to get rid of this fraction. I really don't like having that big quotient in there. It makes things ugly and awful to deal with. So I'm going to multiply both sides of the problem by x, because that's what the whole numerator is being divided by. We've got 4x plus 7 is being divided by x. So we're going to multiply both sides by whatever number it is that's on the bottom. So, as usual, these x's will cancel off, and on the left-hand side, we're just stuck with 4x plus 7, and on the right side, we have 3 times x gives us 3x. All right. Notice, again, we have an x here on this side and we have an x on that side. So we need to combine those things. We want them to all be together on one side, and we want all the other mess to be on the other side. So I'm going to go ahead and move my 3x over. So in order to do that, I've got positive 3x here. I'm going to subtract 3x from both sides. 4x minus 3x is just going to give me a single x. I still have plus 7. And now on my right side, I have 3x minus 3x gives me nothing left. Okay? So if I want to finish this off, I still need to get x by itself. In order to do that, I need to do the inverse operation. We've got plus 7 here, so we're going to subtract 7 on both sides. And we will end up getting x equals negative 7. Okay. So I hope this helped. I know I went through the problems quickly, but I hope this helps to see a few examples. Okay? Thank you for watching.